This question is from GATE Mechanical Engineering 2019. This is question number 16 of set 1. The question is, the position vector OP vector of point P 20, x coordinate is 20 and y coordinate is 10 is rotated anti-clockwise in xy plane by an angle theta is equal to 30 degree such that point P occupies position Q. As shown in the figure, the coordinates x comma y of Q are. So here in the problem it's given that the initial coordinate system or the xy on the xy plane we have a point P whose coordinates are 20 comma 10, the OP vector, and it is rotated in counterclockwise direction by an angle theta which is 30 degree. So we need to find the position of Q here, because now P has rotated to gain the position Q. Now before solving this problem, it's better first have a look on the types of transformations. So let's understand linear transformation. Now the transformation, let's say 2D transformation, can be of several types. Like it can be shear, it can be reflection about any axis, or in this case it is rotation. And that too, this is rotation about origin. Let's not waste much time on shear and reflection. Let's directly come to the point, that is rotation about origin. Let this be xy plane. So this is x and this is y. And this is the initial vector, that is P vector. Okay. And when it rotates by an angle theta, that is equal to 30 degree, it reaches point Q. And we need to find the coordinate of point Q. Qx. Now this is given 20, 10. So the x coordinate is 20 and y is 10. The unit vector in this case is, in this direction it is I cap, and in y direction it is j cap. Right? I cap and j cap in y, x and y direction respectively. Okay, so if the rotation is clockwise, we will take it as negative rotation, and if the rotation is counterclockwise or anti-clockwise, we say the rotation is positive. Now it's important to understand that where this unit vector lies after transformation. When we rotate this P to achieve this point Q, the unit vector will also rotate, right? So, and we will have a new coordinate system that is rotated counterclockwise by 30 degree. So if we can trace where I hat and j hat lands, then it can give us the transformation matrix, such that, suppose T is the transformation matrix. So to get point Q, you can multiply P with the transformation matrix. In this case, let's say rotational matrix R. If you can find where the I hat and j hat lands, we can find the rotational matrix. Let's draw a new graph below. So in case of rotation, let's say this is the xy plane, and this is P vector, right? So P vector can be written as, in terms of matrix, x, y. Now after rotating 30 degree to the counterclockwise, it has point Q whose coordinate can be written as x dash, y dash. In question it is xy, but let's assume it is x dash, y dash. And I hat and j hat are the unit vector in x and y direction respectively. So I hat can be written as, this is the x coordinate is 1 because it's a unit vector, and the y is 0. In matrix we can write it like this, and for j we can write 0, 1. Now I have already mentioned you that if we are rotating this vector by 30 degree, so we can rotate the I hat and j hat by 30 degree as well, and the new position of this I hat and j hat will give us the transformation matrix. Now this is the new unit vector, or we can say the unit vector of new coordinates system that is rotated by 30 degree. Okay, so here I is rotated by 30 degree and j is also rotated by 30 degree. So let's call this as I dash hat and let's call this as j dash hat. Okay, now we need to find the vector I hat dash and the j hat dash. If we can do that, we will find the rotational matrix for this transformation, or for this new coordinate system, we can say. So let's write now if we see here, this is the coordinate of new I hat dash. So if I want to write this I hat dash in terms of the xy plane, that is the older coordinate system in xy, we can write it as x has moved by 30 degree, this value of x, so we will write the value of x from this point to this point. That is how much? That can be given by 1, since the magnitude is 1, so we write 1 into cos theta, that will give you cos theta, right? And the y coordinate, so y is how much? From this point, from the origin, let's write O for origin, to this point, right? That's the y coordinate of this I hat dash. So this is 1 into sine theta, right? So we can write sine theta, right? So this is the new coordinate for I hat dash, or we can say new unit vector, right? This cos theta and sine theta, let's give it. Now we trace the j hat dash, where it lands. Now it is landing here at this point. So the x coordinate will be in the negative direction and it will be given by, so the x coordinate of j hat dash vector, the unit vector in the new coordinate system in terms of the older coordinate system, we can write it as, so it is moving by 30 degree, 90 degree, 90 plus 30, so that is cos 90 plus theta. This is the x coordinate in the negative side. The y coordinate is still positive, but it is the length of from this point to this point, and it is given by this is given by sine 90 plus theta, so this will be sine 90 plus theta. Okay, now if we can, this can also be written as cos 90 plus theta, this is minus sine theta, and sine 90 plus theta is cos theta. The transformation matrix is the rotational matrix, so let's write R. So the rotational matrix will be the I hat and j hat. So I hat is cos theta sin theta and j hat is negative sin theta cos theta. This is the rotational matrix that if you multiply it with P, you will get the new coordinate system Q, right? So this can also be said that if you multiply the unit vector, with this R, so you will get the new unit vectors that we have just seen. Okay, so this is just the rough work, just to make you understand that this is the new coordinate system or the unit vector of new coordinate system, and this is the older coordinate system, that is I hat and j hat. This is I hat dash and j hat dash. Now let's apply this to our problem. What we will get here is, so before that, let's write a statement here. It's very important to understand. Any vector that is in this xy plane multiplied by this rotational matrix R will give, or will be rotated by 30 degree in xy plane, Now coming back to our problem, we can write, as we have already established, if we want to get Q, we need to multiply P with R matrix. P, the coordinates of P we already know. P is 20, 10, and R is cos 30 degree, sin 30 degree, So this is I hat. Now let's write the j hat, that is negative sine 30 degree to cos 30 degree. Now let's write the values of cos 30 is root 3 by 2. So this is root 3 by 2. Sine 30 is 1 by 2. Cos 30 again, here it is root 3 by 2. And minus sine 30 is minus 1 by 2. So if we perform the matrix multiplication here, we'll get Q, we will get as 12.32 and 18.66. So these are the coordinates of Q, that is x is equal to 12.32 and y is equal to 18.66. Now let's match this with the given options. So if we see here, option C is the correct choice. Now let's go to the reference here. If you want to get more information on rotational matrix, you can refer to the NPTEL course on selected topics in mathematical physics by Professor V. Balakrishnan, Department of Physics, IIT Madras. Hopefully I was able to solve it out. Have a great day.